before we do that, we should welcome David to the Acryl Data team. David has been a part of the community for well over a year at this point, I think,
Yep.
and recently joined us. We are just absolutely thrilled to have him.
Yeah, happy to be here. Awesome team. A lot of actually what I'm talking about right now for performance improvements is actually work that was done, by the team before I got here. So I'm just kind of like giving a shout out to the great work that's being done here for, really kind of improving the performance of DataHub itself beyond what most people are going to need. So we can go ahead and get started. So one of the situations we have is especially when we're bootstrapping an existing environment is we have a lot of data sets to onboard. And so the initial version of DataHub has a synchronous ingestion system where those new ingested assets are being stored right away into the database, the MySQL database. And so what we've actually done is an asynchronous ingestion path. So what? Is there a way for me to switch the chart? Perfect. We've allowed you the ability to basically ingest asynchronously. So you can fire off a ton of requests for new data sets and things like that to the API, and those will be dropped into a Kafka queue. And this queue can be processed asynchronously in the background. So you can dump, a million ingestion requests in there, and they'll eventually be processed and pushed into the application. And so that's, again, scaling ingestion. Some of the other performance improvements that are being done is with glossary terms. So there are some customers who have literally thousands of glossary terms on either the terms or even on a single node. And so some optimization improvements was done with the way that the GraphQL query is structured to prevent fetching information on the parent nodes where it's not needed. It's actually not shown in the UI. And by reducing that overfetching of data that we're not actually displaying, we can improve the glossary terms loading by 80 to 90%. So that's much faster. The other thing that we have is we have a write optimization for our Elasticsearch graph. So if it take, for example, our data sets have relationships to other entities within the system. And what was happening before is that these edges were being removed and recreated unnecessarily. And so now there's logic in there to actually compute the diff, which edges should be removed and which ones should be preserved and or added. And then that's applied in a much more efficient way, which means fewer updates that are being sent to Elasticsearch unnecessarily. So awesome performance improvements there. And then we have another case of Elasticsearch where we're really looking to scale the number of entities into the millions. And so when we're talking about, let's say you have a million data sets, even 2 million data sets, you're still looking at around 1 second or less, considerably less as far as response times in the UI. But what if you actually have, 5 million, 10 million data sets? What do you do in that case? Can DataHub scale with your growing requirements? And the answer is yes. And so what we've been able to do is basically allow you to shard your index in Elasticsearch, which basically means, take a large index and split it up into multiple pieces. And you only really want to do this on these largest data sets. And so what we've looked at, like, when would you want to do that, and then give you the ability to do that if you're running your own system, or if it's managed by us, we'll do it for you, of course. And so the top 3 indices that are going to be kind of like, depending on what your environment is, but most likely it's going to be data sets, system metadata, and the graph service indexes. And there are essentially rules of thumb that you would apply. So in general, you can take a look at your indices and see, like, I've got an index that is 40 gigs. And in that case, you're going to want to shard. The first kind of step up, like if you're going from, let's say you've got 5 to 10 million documents, you probably want to have about 5 shards. And then as you grow and as you see your, say, slow response times from the search or browse paths, you can increase the number of shards to reduce the latency. And so we can kind of help you with some best practices on how to do that in your environment. And then here's an example. So this case, but before sharding, the latency was about 7 seconds for this particular data set. This particular data set had about 7 million records in it. And so now we can reduce that to about 1.5 seconds. So again, like at this point, we might consider some additional sharding in order to get that back down to less than 1 second. But a lot of it is trial and error because the shapes of your documents could be different and things like that. So there's a little bit of trying to figure out what's right for your environment in this whole thing, but lots of improvements. And I forgot one slide, I apologize. There's another improvement that deals with caching, entity caching. So again, reducing the latency in the UI for returning objects that are actively being used by a lot of people concurrently. So there is caching at the entity layer, and I think there's going to be additional types of caching that we're going to roll out into the product as well, again to improve the latency on the UI. And that's it for me.